Right. Well, good morning, good afternoon, and good evening from wherever you are in the world. Thanks for coming out for day three, and this is session one of the J Champions Conference. More than happy to be moderating Oleg Shelayev's presentation on test containers. So he's a developer advocate at Docker. And so if you have questions, please put them in the chat, and I can actually pop those up for Oleg to view. So, all right, with that, I'm going to disappear, and I'll pass it over to Oleg.
Hi. Let me actually find my button here for screen. Wait. So today we're going to talk about tests. And today we're going to talk about developer productivity. And today we're going to talk about velocity and happiness via tests. I'm a big advocate for tests, and I am an advocate for developer productivity, which I personally think is not just about delivering business value faster, but also the teams of developers who are happier. They bring more innovation. They bring more impact throughout the company. And of course, they also are more productive in bringing more changes with useful business value forward. And when we talk about very much productivity nowadays, it is actually what the discourse is around developer experience. And there are a number of things where in the industry through the past years, how this developer experience became sort of the point of our discussion. The notorious DevOps movement and DevOps process as a culture started with uniting developers and operations concerns and making sure that everyone on the team understands that applications are not just written, but they need to be also deployed, maintained, monitored, and operated. And the same way, not all the changes in the environments, in the operations can be just done willy-nilly in the production, but the changes need to originate and be communicated with developers, so it becomes a single cycle. And then DevOps, the topic slightly started shifting from just building this united culture into platform engineering, where there are, of course, separate areas and separate topics, but the narrative of the industry very much started shifting a little bit for how do you internally at large companies or within large teams enable your engineers be better DevOps better at DevOps, better at delivering code and value to businesses. And then platform engineering, which is, of course, when you have when some teams within your company provide you with tooling to kind of sort of do things that you need, kind of started migrating a little bit towards more developer experience. And the same with developer relations teams across many companies, especially product companies, started becoming more, not just relations, not just a marketing aspect of working with communities, but thinking through and actually working on developer experience. So it converges to developer experience from different points, trying to make your communities, trying to make your end users, trying to make those end users as like developers who actually will write applications using your stack or using your tools more productive. What is developer experience? It's a sum of all positive and negative experiences and feelings that your users have, right? They work with the particular aspects of the processes within your team. Your developers work with particular tooling that you impose or they impose on themselves within their processes and teams. And the whole feeling, how they work with them, is developer experience. And allegedly, and this is very natural thought, good developer experience will boost efficiency, will keep developers happy and committed. And if the sum of all experiences is negative, work becomes a chore, work becomes slow, change becomes slow. And when change becomes slow, the DevOps cycle or DevOps loop starts stalling, which is not great. And we're going to talk about exactly that, how tests can improve both productivity or stall, actually, if you incorrectly build the setups. How tests improve or stall your developer experience and productivity. My name is Alex Shalev. I work on Testcontainers and developer relations team at Docker. And you can find me almost universally by @Shalev in all social networks. I am a Java champion. I was a Docker captain at Atomic Jar, which is my previous workplace. And Atomic Jar was a startup maintaining the Testcontainers libraries. And it was acquired by Docker just recently. So that was the move. And luckily, I could join with the rest of the team. And luckily, I can continue working on Testcontainers, which is why this presentation has been born. If you want to follow me, or if you want to interact with what I provide, I recently started doing shorts videos on YouTube. So that's my preferred social networks to kind of sort of share it here with you. You don't have to, but I go to conferences fairly often, and then I can ask questions from people to people and then post the answers on YouTube, which is very cool if you ask me in my boomer's opinion. I didn't say that. In my older person opinion. Sorry. That's cool. You don't have to. Right. We're going to talk about Testcontainers. And since I work with Testcontainers, my views on tests, or how tests could be, or what tests, what they should look like, or what they should give you, might not strictly be the same as yours. Your experience could be different. Your projects could be different. Your view on the industry, what types of applications you are building, could be different from my experience. So you might have different opinions. But I think if we look at the more generic side of things, this presentation stands. And I will not try to, this is not a presentation to try to sell you Testcontainers. Testcontainers in general, if you don't know, is an open source collection of open source libraries. It gives you programmatic API to do things with containers, and allows you have your service dependencies as code from within your application available in 10 languages. So you can just use it. I will have a demo of Testcontainers, but that will come way later. So I tried not to be overly excited about the particular types of tests, but just thinking about in general what are good tests and what are the patterns that will bring you down. So with that said, what drives productivity? Everyone wants to be productive. Teams want to make sure that developers are productive. Companies, it's like there is a whole industry, and it's very, very hard to define developer productivity. Is it the lines of code that we write? Absolutely not. Is it the amount of tickets issues we create and close? Well, that is definitely not the measure, because everyone would be able to write themselves a minivan by lunch at any given day. And it's really hard to measure productivity objectively, or measure what drives productivity objectively. It's usually done through surveys and feelings and just external metrics about how the team is doing. And it's very, very much non-uniform, because it also varies greatly by the quality of the particular engineers in a given team, by the consistency of the team, like more junior engineers versus only senior engineers on the roster. So it's very, very hard. So recently, there was this academic paper about measuring and improving productivity. And they did an excellent job exploring the past research and also trying to put all these fluffy feelings into particular axis of productivity. And the result was that most of what people mean when they say they're productive or not can be mapped into 3 core dimensions. This is the flow state, the feedback loops, and cognitive load. Those are the pillars of developer experience, and improving those and working on those can make you more productive as a team. Let's look at them in a little bit more detail. Feedback loops. Feedback loops mean how fast you get a reaction to a particular change, whether that change is good, whether that change goes in the right direction, and whether that change actually breaks anything else in your application or in the larger system that it shouldn't break. Well, slow feedback loops, as any feedback, are inefficient. Developers will have to waste their time waiting for the return signal. And this could be multiple things. This could be waiting for the code review. This could be waiting for your CI processes to finish. This could be waiting for your staging environment to propagate the change. This could be waiting for your QA team to verify that a particular set of changes were actually on point. And it's very, very easy how insignificant feedback loops, when you just wait a little bit, they actually add a lot to interruptions. Even a short break of a couple of minutes will probably lose you for 15 minutes. You're going to go get a coffee. You're going to go scroll TikTok. And then that's going to be it. So faster feedback loops are good. Cognitive load talks about the amount of mental processing that is required for you to perform a task. There are 3 main questions to this. When we actually need to implement a change in the code, there are 3 questions that we need to ask. What does the code do in the particular place? Why does the application does it in this way? And how to do it in another way that you want to achieve. So you need to change things in a very precise way. And if you think about the greenfield application development, you might not grasp how important this is on the first try. But if you ever have experienced maintaining maybe an older application or a larger application or an application written by developers whose mental model was slightly different from yours, you definitely know the feeling where you need to find where the things are that you need to change. You need to change them, and you need to verify that you actually didn't break anything. You need to keep a lot of moving details in your head, and that is hard. And the more details you need to keep in your head, the harder it will be for you to change things without breaking. Small things like, oh, can I forget a semicolon? That is minuscule on the scale of larger systems. But if you don't have to think about whether you need or do not need a semicolon, you can be more productive, slightly. You don't need to think about a particular syntax for your esoteric language that you chose for the project, or maybe some libraries where there are not so many experienced developers on the team. Then you will have to keep less or more in your head. And the last pillar is flow state. It's a mental state when you are fully immersed in the activity that you're doing. Preferably also enjoying this and feeling progress. Achieving flow state usually comes when there are no interruptions or delays, and flow state is a very it's hard to actually qualify with numbers, but in the flow state you can continue working and making progress on the particular issues very rapidly for a long time. You keep the required cognitive load state in your head, you may making progress, there are no interruptions, and sort of the work flows almost automatically. If you have interruptions, your flow state resets. You will need to load everything in your brain. You will need to understand what you were doing, and then come back into starting working. The most natural and then sort of the classic flow state interruption is the weekend. If you think about how productive you are on the last day of the week, and then how you need some time to get into the same state, for example, on Monday, after you come back after a weekend, that's it. So my immediate tip here actually is, it's separate to the main point of the presentation, but finish your week with writing a test that fails for whatever you are doing at hand. Just write a test that fails. Even if you don't feel like anything is failing currently, you don't have to participate in practice test-driven development, nothing like that. Just write a test that fails, and then leave it in that failing state for the weekend. It's hard for some people, but like, you will come on Monday, and then on Monday you will see that failing test, and you will start fixing it, and you will immediately get into the flow zone state much better. So feedback loops, cognitive load, flow state, 3 pillars of developer experience. My claim is, and it's not in those papers, and it's not in the analysis of those papers, but my claim is that good tests can improve all 3 of them, and bad tests will stall them. And even more, a stronger conjecture, that if you have bad tests, if you have test suites that are you cannot trust, if you have test suites that are slow, if you have the test suites that is just hard to work with, nothing will actually help you improve developer productivity very much unless you fix those issues with tests. That might not be true. Your main maybe drain for developer productivity could be something else. Maybe you're scheduling meetings for developers every hour for half an hour, and then the actual work time could be only 30 minutes at a time. But I think tests are absolutely essential. So, and tests very naturally impact all 3 of those. So let's look at the very particular one. Developer productivity flow with no interruptions. If that's very clear that it takes some time to ramp up to get into the flow zone productivity, when you actually are working, when you understand the context of the changes that you're doing, and then you are performing at sort of close to peak level. What activity during your sort of inner developer loop breaks this flow state the most? I would argue this is tests. Searching where you need to change things is the natural activity. There is only you are doing that. Something is you are actively doing that, and nothing else is actively participating in the activity. Reading code, writing code is very similar. Building code, this is interesting, but I think for the most part, the industry has moved from the setups where build times locally are an issue. It might be different in different programming language communities. If you're writing systems in, I don't know, C, C++, working on the browser, then maybe build time will take quite a bit of time. But in the Java ecosystem, at least, builds are incremental, builds are fast, and local builds should be a negligible time. And then there are tests, and tests are where bottlenecks happen. Very many surveys, different surveys say that people both consider that they spend too much time on tests, and then they also don't feel that they're productive enough working with tests. And commit comes usually once in a while, so like it's a non-issue, even if you have to walk for 5 minutes to figure out a good commit message. So test is where the concentration breaks and where your flow becomes suboptimal. And it's not just me. Many teams discover and advocate for the same. For example, from a recent presentation by Roberto Alcalia from Netflix on their, he works on the internal platform and responsible for improving experience to tests. Testing is crucial in the inner loop, and a suboptimal experience leads to both context switching and losing flow state. Very natural. So let's talk about how bad tests impact your developer experience, and what does it mean to have bad tests? Like how can you look at the test suite or a particular project and tell that, I don't think working with this project, judging by their tests, will be fun. I don't think it will be very, very productive. I assume, as most developers are similar to myself, and like working on something and being productive feels fun and makes you happy. And feeling unproductive makes you sad, or at least not very happy. So let's look at some anti-patterns of the tests. So the first one is that there are lack of tests and testing is difficult. You don't know how to add a new test that will particularly verify the changes that you're trying to do. Testing is difficult, and that makes it makes creating new tests or changing tests interrupt your workflow very, very much. You try to avoid tests or writing new tests. Maybe you can run still the existing tests, but you try to avoid writing new tests, and that stalls your productivity because it doesn't improve the situation. If tests would be easy and adding tests would be easy, the situation would gradually improve. But as soon as testing becomes a chore, you stop doing that, and you will try everything not to do that. Like you would try to do the fun parts of the work and then not do the difficult parts of the work. So you'll have less tests, and then that will be the end of it. Tests are flaky. That means your test suites lack confidence. When some tests fail, that should be a clear signal that things are broken. When the tests pass, ideally this should be a signal that your application is working as intended. This is a high bar to clear. Normally, most projects have tests, but also it's not that common for the tests to be the automatic gateway into deciding where the particular commit is of good quality or not. Flaky tests are especially nasty in ruining developer productivity because they fail for no reason on your own. They fail because, because today is Tuesday, or because the weather is a certain way, or because the time zones have shifted recently, or because currency or user input. There should be no user input in the test, but they fail for no reason. So you cannot fix them by changing the applications. You have to fix them by changing mostly the tests, which is clearly not a good signal for the application quality. So there is certain, the whole knowledge and the developer tooling, how to work with flaky tests and setups where they can be rerun automatically or improved or highlighted initially, and you can work with that. But flaky tests are bad, and then that means that you don't want to trust them. And that stalls your developer productivity because it imposes additional overhead on introducing changes. And then you can have tests, but they're slow. And if your tests are slow, then, you're not going to run them. And if your tests are slow, that means different things for different people. And it also means different things for running tests locally and in developer experience, in CI, continuous integration environment. Locally, I would run tests if they run under maybe 3-4 minutes. I would, of course, while developing my application, I will run my tests individually, so I don't have to run all the tests. But once in a while, I can run tests for a few minutes. That's no big deal. But if they take a lot of time, if they take like 10 minutes per application to finish, that will be a very massive interruption, and that will make me avoid running them. That will mean 10 minutes locally is a long time. 10 minutes in CI is not a long time. So I will run the test, but I will defer them to continuous integration environment to give me the answer. That will, in itself, introduce a huge addition to the feedback loop. If I need to wait for the CI to tell me whether my application's my changes are correct or not, that means I added a massive bottleneck into my development process. I can still maybe run individual tests locally, but if I rely only on CI and I don't want to run tests locally, I will then start avoiding running tests locally even more because the CI is the source of truth. And then I will not verify my changes locally. And since this is a little bit vague, I wanted to include one more example where tests should not be super tightly coupled with your application. Imagine you have a calculator like this, right? It's a very basic calculator. There are two methods. The subtraction is a reversed addition, and you get the results. If you want to test this, and if like this is a very simple piece of code, so a little unit test will be absolutely fine, saying that, oh, let me just provide inputs, get outputs, maybe some property-based testing that will generate the boundaries for my test use cases automatically. It will be fine. But if we start making tests rely on the actual implementation of the code, for example, we're gonna mock our calculator and create a spy object on that, and then we're gonna verify that actually subtracting two integers actually does that through the addition. It's an overkill for such a simple thing, but as soon as the application starts growing in complexity, you will start feeling the need to mock parts of your application and just verify the behavior of those components in a tight manner, in a tightly coupled manner like this. What will happen with this code is that now it rejects change. It resists being changed, because if you change the implementation details, for example, somebody sensible comes and sees that there is no point in using subtraction as a reverse addition and just rewrites the answer in a sensible way. What happens is that the tests break. And that is a very, very unfortunate situation, because we didn't actually change the contract of the calculator. We didn't change what the code does. We only changed what the code looks like. And our tests, instead of being the guardrails for behavior, they start resisting change at all. So if your over-reliance on mocks is a very, very unfortunate situation where you will not be able to make your code behave the same but look differently. And then you will not have fun, because any change will mean that you need to rewrite the tests. And that is definitely not something that you want to do. So what do high quality tests look like? What are there was some noise. Do you want to ask a question? Are we?
Oh, yeah, there was a question from Frank Ware. I popped it up on the screen. I don't know if you can see it.
Wait, let me find it. Please address the testing wisdom if the data used is from external data source and may not be consistent. Ooh, that's a very good question. So the data used in your tests needs to be of course standardized, right? might not be consistent, but you are in control of the tests. So you can structure the tests in a particular way. Wait, is this a question about AI, Frank? Is it a question about large language models giving you different output that you need to rely on in the tests? Because that one, I don't have a good answer yet. But like if we talk about just the data, say, and the data for your tests is, say, a snapshot of the actual live database, anonymized and minified for your purposes, then the answer is that you work with a subset of that data and you test the pass in your code that you actually need to rely on. So you probably want to have the happy path covered. You definitely want to have some negative paths in your data covered, which is where the inconsistency of data actually makes sense. If that data is what you work with in production, that's actually a good thing. That gives you consistency between environments, and that allows your code to handle that inconsistent data. If you're talking about AI, I will owe you an answer. I need to think through how to test applications that deal with AI subsystems and components, and I don't feel confident answering it right now. But if you find it, just drop me a note. I'm very interested in this as well. Maybe we can talk a little bit at the end of the presentation about that, because it's a very interesting situation where your actual setup brings uncertainty and element of non-determinism in your test setup. Usually with normal randomness, you want to fix the source of randomness, like a seed or something, to a certain value so you can reproduce things. But I'm not sure that works with the large language models the same way. Right. So what are some qualities that you want in your test? In general, what do you want your test to be? You want the test to be novel. You want your test to be reproducible. And you want your test to be significant. These are actually the qualities of academic work. Your academic work, and as a PhD dropout, I know everything about not producing excellent academic work. So not everything, but something. You want your test to be reproducible because you want your tests to be the single source of truth in CI, and you want to be able to reproduce them locally, individually. You also want your whole team work with the same set of guidelines, what the application behavior should be. So you want everyone to be able to run the tests in the same manner. You want tests to be novel. It doesn't make sense to run tests again and again and again for a particular piece of code or with the similar inputs that verify the same behavior. It just takes too much time and creates unnecessary work. And you want your test to be significant. This is coming back to the confidence signal from the tests. If the tests break, you want to know that you actually broke something in the application. If your test didn't break, if all the tests are green, you want to be able to say that, you know what, the application is in good state. It's very, very often is not the case, especially if the writing tests are hard. If creating new tests is hard, then you would naturally try to skip on adding sufficient amount of tests, verifying sufficient amount of behaviors. And then while one-way signal of when the tests break will tell you enough that, yeah, something is broken, you will have very, very hard time trusting your test suite to have like the green signal means go. It is possible to achieve that, but it's very, very hard. That also means very often in the modern environments, it very often means that this pyramid of tests could be rethought. We could think differently. If we want our tests to give us lower coupling with the implementation details, if we want our tests to have higher confidence, maybe not just for application, but that it works in a larger, as a part of a larger system, then integration tests might take precedence and might become the bulk of your test suites. You still need implementation detail tests, right? I'm not saying that unit tests are inherently bad. If you have a piece of code that you need to verify in isolation that it works, you should have unit tests. But if you have systems that need to talk to other systems, or if you have complex components in your application, then you need some sort of integration tests. For example, in my previous life, I worked at the GraalVM project, right? And then there was the compiler, of course, the just-in-time compiler with additional optimizations. You would think that you should cover all of that with unit tests, right? You just look at the compiler, feed it a piece of code, and then see the outputs. That is a very, very useful test for the particular optimizations for just-in-time compiler, right? After all, just-in-time compiler is an isolated component in the system, right? It doesn't integrate with anything. It just takes code in, outputs machine code or more optimized bytecode or whatever, depending on the actual implementation, what the compiler does. Is that right? Wrong. One part of the, for example, at least in the JVM world, one part that the just-in-time compiler integrates with is garbage collection. Your just-in-time compiler needs to know how to work with the garbage collection algorithms that are also present in the JVM, because people might run with the different combinations. Does it work with parallel? Yeah, maybe. Does it work with GMON GC? Probably, but you need different tests because the compiler needs to actually be aware of the garbage collection to introduce certain code patterns, right, to satisfy the GC invariants. Will it work with ZGC out of the box? Well, it could, but it also most probably will require work. So just running unit tests, just verifying that you can do transformations on, say, abstract snippets of code, like abstract pieces of code, is not enough. You still need to run some sort of integration tests, even for such a low-level component that you think works in isolation as a just-in-time compiler. So the higher level tests usually give you more confidence. Also, the higher level tests historically have been slower to run and harder to maintain, which is in the recent years started being less and less so. Maybe not for the just-in-time compiler, but for the typical applications that most application developers are working on, the situation has improved dramatically. So, and think about this. We looked at the calculator code, right? If we have an integration test that just tests higher-level components in an application using the abstractions that your application framework, in this case Spring, gives you, right? And if you verify high-level behaviors of your applications, that, for example, you can get products from the inventory by referring to the code, that piece of code will not break, even if you refactor the whole application away. You can, for all you know, you can change the programming language that you're gonna use to actually implement that application, right? And the test will still work. That means that once you cover your functionality with those, no one else will break them. And surprisingly, at the current stage of how the integrations with and how the application frameworks behave in the Java world, running a test like this doesn't take significantly more time than running a unit test. It looks exactly like a unit test. You can run it individually in your IDE. You can literally click on it and run it. You can run it from the command line. Your CI can run it, and it will verify behavior very, very well. Talking about CI, right? One very important concept in, well, 12-factor applications or 15-factor applications is environment parity, which historically has meant that whatever we do in production should also be the set of technologies, or the environment in production should be the same as in development. This is sometimes very, very hard to achieve, but if your development environment is completely different and the way you run tests completely doesn't represent production, then your confidence in the tests will be fairly low. So you want the environment parity, and you want environment parity actually to include your continuous integration environment, right? You want your, in this setup, you actually want your CI to become a single source of truth. It runs your tests, preferably fast, and then it gives you an answer. It uses the same set of technologies, or as close as possible, to maintain the confidence in it that you would use in production. And your development environment uses the same set of tools and the same set of technologies to run the test that CI does. So it enables your feedback loop not to go all the time to CI to run individual tests or to run tests for your changes, but you can run them in development, but you still, whatever you do locally doesn't actually count. It helps you fix issues that are found in CI, including by issues created by other people, but it doesn't prevent you from working locally in your setup, improving the feedback loop. So that is where test containers very often helps different teams to achieve this environment parity for both running the tests and actually running the local local setup for your applications. This is not the super fresh concept, but this is something that I would like to show in as a demo. Imagine you have a Spring application, and that Spring application just works with some particular, you don't need to know the full details, but it works with some data and it requires a database, and you need to run this. And of course, in that application, you can have some tests that will create the environment and then use the application code to do something and verify that the application behaves correctly, right? In my case here, I will use test containers to create environment for my application. It needs a database, so I will have a MariaDB container that I will create. I will run it. I will instruct Spring Boot with a service connection annotation to use that as my primary database, so I don't even need to pass the configuration details where my MariaDB container is running. I will also create a max scale container. Max scale is a proxy to MariaDB that can give you additional functionality for this. The exact details of how I create this with test containers is not super important, but it's fairly easy to do that with any Docker container. So I can just run MariaDB max scale. I will put the containers on the same network so they can see each other. And I will configure my Spring application to use max scale as the destination for my MongoDB, right? So, and in my tests, I just use my application normally. I will use the Mongo template to save the data into that, and I will use my bean in my application here, full profile repository, to get the application data from the MariaDB using a SQL code, like a query. The particular details of the tests are not that important. What is important is that I can run my tests, and the tests only require a Docker environment to be exposed. So test containers can actually pull the images, start the containers, configure the containers, and then expose them to my application. My application runs locally. So it will work the same way in CI or when I run this test locally in my local environment. But what is even better at introducing this consistency between development environment and CI is that I can also use test containers based approach for running my application locally, right? So here, I will create a configuration for Spring Boot. Other frameworks in the Java world have this functionality also. For example, Quarkus has it in the forms of dev services, which is from the very early days of Quarkus is an amazing, very elegant solution for creating environments on demand for both tests and running the application locally. Micronaut has Micronaut test resources, which implements a similar concept. And Spring Boot, since last year, also has this way of doing this generically for any Spring Boot project rather than implementing this locally for yourself. So you can have a application in your test class path, and you can use the same code for creating the environment for your tests through a configuration object or for running locally. And then in your test application, what you can say that you want to run your main application from the main class path. But also because you're in test class path, you can also use the container configuration that you use for your tests. And you can just run this locally. So when I run this application, right, like this, right, what it will do, it will use the test containers library. It will find my Docker environment. It will pull the necessary images if I need to. It will start my application the same way it starts it normally, and it will access it through whatever this current bean. And my application is running, and my environment is running, and I can even see my containers being there available in my test containers desktop application. You don't have to use that for test container setups, but locally, working locally with that, it helps. It gives you some functionality for test containers specific use cases, knowing the containers go up and down and so on. The important part here is my tests and running application locally, when I want to just explore how it behaves, follow the same environment, follow the same setup, and I can reproduce my CI failures locally, both run by running tests or exploring and working with application locally if I choose to do so, other than trying to introduce everything as a test, which is actually might not be the bad idea, but well, depending on whether you subscribe to the ideology of writing tests ahead of introducing changes to your code or not, might be a slightly controversial topic. So you want your setups to be the same. You want your setups to work. If you're using test containers, it works out of the box for you and your team members. If you're having other setups, you might want to look at the test containers, but also it might be necessary to use other setups. But what you want to achieve, you want to achieve this situation where you have environment parity and you have CI as a single source of truth. And then, of course, with the tests, as soon as they go higher in the hierarchy of complexity, and integration tests are definitely they involve more components than a single unit test verifying behavior of just a snippet of code. So you need to start thinking about speed optimizations. There are a number of things that you might want to look into, and this is for any type of test. We are not talking about just test containers, test speed optimizations. You want your feedback loops to be as fast as possible. You want to be able to run individual tests. You want to be able to run individual tests or subset of tests without relying on the particular order of executing tests. And definitely in CI, you want to try to look, or at least not prevent yourself from the optimization possibilities, such as parallelization, which is very, very important. And you want your environments where you run your tests be beefy enough that just running the tests doesn't overload them and doesn't stall them in the basic performance optimization problem. Right? If you're running with very tiny workers and you want to run a lot of code, that will be slow. So you might need to work with your internal platform team or developer experience team and figure out a way to beef up your CI environments. So all in all, if you have tests that you trust, if you have tests that are easy to write, that are not coupled to your application code implementation, and that are easy to change, you get the benefits of being more productive. You want your tests to be a part of the sort of the paved road, whether this is for your individual project or even better for the larger set of projects at your organization. You want ideally the unified way to write new tests, set of technologies that you use. That includes set of technologies for creating environments, like for example, test containers. That includes set of the libraries that they're using for using the API tests, like for example, rest assured. That includes set of the libraries that you want to run for the test mutation tests, where you change the code in a random way and then you run the test and you verify whether changes to the application actually broke anything, and you can find untested but important pieces of code. You want to standardize on that. You want to make it as easy as possible for the regular application developers who might be more junior than you to use that without actually introducing a ton of cognitive load, right? Remember, we don't want to overwhelm developers with thinking about tests. We want them just to write tests and run tests naturally, as if that was the easiest thing in the world. Paved road. You don't want your tests to be slow. Oh, I didn't expect this to run. There's an excellent presentation from the last year's DevOps by Trisha. Are your tests slowing you down? Where she talks about automated tests, and she talks about the being in the zone and being the flow state, and how you don't want your tests to interrupt with that. So she shows there some tools and approaches how to identify issues, identify which tests are slow, identify which tests are flaky, and fix that. It's an excellent presentation to look at. I removed the play on click, but it's automatic count. You want to look maybe at a video from the Developer Productivity Summit from last year's about how Netflix introduced and improved the test containers, their testing experience by creatively using test containers and Gradle Enterprise Develocity test distributions to give developers very, very easy way to run tests in the same fashion, whether in CI or locally using the CI workers. And there's just a very, very recent blog post and some academic research as a follow-up to that, what makes good developer experience and the pillars of developer experience. This same team, I don't want to be wrong, another team, some people researched the data from multiple teams, and they verified actually that cognitive load, feedback loops, and being in the flow improves developer productivity very, very much. They don't talk there about tests, but if you squint your eyes slightly and you will think about how without having tests, it's really, really hard to introduce any changes to your code. You can also get the output that introducing better tests will improve your developer productivity. And then if you want to look at the original data that they found and the paper, you can get some quantifiable metrics like developers who report understanding of the code, better understanding of the code, are 42% more productive than others. And if developers find their tools and processes intuitive and easy, they can be 50% more innovative. Whether you want to trust those numbers or you want to take the actual, absolute values with a grain of salt, it's an interesting read, and I hope it will inspire you to create a better developer experience in your teams or in your departments or in your individual projects. And I hope this session will inspire you slightly to maybe look at your tests, not just as, oh, this is a quality control for whether my application does the right thing, but look at your tests as the essential tool in moving your application forward, introducing change, and the gatekeeper of developer productivity. I think this is it from me. So we are at the end. So I think.
First of all, thank you, Oleg, for an awesome presentation. We had, first I wanted to mention, we had people from around the world joining us today, from Lille, France, Denmark, Brazil, Germany, Georgia in the United States, San Francisco, London, Senegal, and Belgium. And of course, as I mentioned, I'm from the great state of New Jersey. But yeah, so I wanted to, a comment earlier in your presentation was from Marianne Varga, who said feedback is king. That's when you had discussed. So the first question here is up on the screen from Daniel. And I'm going to read the whole thing because there was a part 2 to it. He says, what do you find is the optimal way of initializing your test containers databases, as well as keeping those schemas and data up to date? And then part 2 of that was specifically for Spring Boot applications.
Right. There are a number of ways to initialize your database working with test containers. Test containers, of course, provides you with a sort of a thin wrapper around the Docker API, and then with some ecosystem of modules for particular technologies, but it doesn't impose a particular way to work with data. My favorite would be to have my application use a database migration library for actually introducing changes to my data. And then I would have a snapshot of my data, just that is repeatedly sort of local to this certain point taken. I would use that in the same fashion. I actually wish I stopped sharing. Wait. Let me put it back. Where's my ID? Right. In the same fashion I'm doing it here. I would copy that snapshot file through the container. It usually goes into the Docker entry point in a DBD folder, depending on the actual image that you're using. Most of them correspond to the same convention, right? So Postgres, MySQL, Oracle, and so on. I think very, very few might use something different like this, right? I would copy that snapshot file in there, and then I would allow my application to run migrations on top of this. And then this way I will check the migrations, I will check that it works, and I will actually also not have to create multiple, I will recreate the data again and again and again from scratch, running thousands of migrations. And then if that is not enough, if you want your data to be more readily available for your tests, I would look at the database specific technologies currently to work with that. For example, Postgres uses the feature called templates, where I would programmatically initialize my data once. So for example, I will copy my schema file to that particular directory. And then when my application has started, I would snapshot the data by making the particular database a template. This is very Postgres specific. Other databases give you similar functionality, but they call it different. In Oracle database, for example, it's Oracle pluggable databases and stuff like that, right? So I would mark a certain state in my database as a template, and then when I will call reset, I will just drop the existing database that my tests might have messed up, and then we'll recreate very quickly from the snapshotted database saying that, oh, just copy test. This is very, very quick, implemented in the actual database. So that would be probably faster than applying migrations, usually in a synchronous fashion to the database. So you can look into something like this. I don't think there are very many out-of-the-box created solutions for using those template databases, but that would be my next step after I've just done the snapshot and migrations.
Okay, we have one final question from Sebastian Berger. Do you recommend using tools like Flyway for database versioning?
Exactly. So database migration tools are a massive, massive help for you. They will both allow you to work with the database that is very much production-like. It's also a part of the environment parity, because you probably use database migration tools like Flyway or Liquibase in production, right? I hope you don't just give your operations people or whoever operates your code, whether this is you or not, you don't give them like a war file or jar file and say like, oh, this is a new version. You need to add a column to table X, and then have them manually execute scripts somehow or manually write scripts. But you use database versioning migration system in production, and you should use that in your tests. This will allow you both to test migrations and have that environment parity. And if you need some test data, my recommendation would be to add the database migration files for the particular data in your test class pass. They will not be included, those migrations files will not be included in your main application, so they will not ruin your production environment. But in your development, when you run your tests or when you run the local development setup, they will include some migrations from the main class pass, and then at a certain points, you need to implement the versioning yourself. But I'm certain that you can do this if, for example, you just version your production migrations by tens, right? And then have the intermediate numbers reserved for test migrations, right? You can create this test data at the certain stages of the migration story, and you can run them, and you can introduce data in your test as well. For example, if your database can work with some inconsistencies because this is just the nature of application. I don't know, you are building a system for hospitals, and sometimes people go into hospitals when they're unconscious and they cannot provide their identification, right? So that data is there in the database because people are treated anyhow, right? But that might introduce inconsistencies in the data. So you might want to check stuff like that and introduce also inconsistent data in your tests, but you want to do this in a flexible manner, right? So that's my approach. Absolutely use versioning for the databases.
Awesome. Yeah, and Eric chimed in and said he is from New Hampshire, so which is a few hours north of me. So, but yeah, there was a lot of comments on thank you for the answering the questions, and thanks for this insightful session. So with that, up next, just probably started a couple of minutes ago, Frank Delport is going to speak on what I learned about OpenJDK as a docs writer. So enjoy the rest of the conference, and I'll see you all tomorrow for moderating one of my sessions at that point. So take care.
Thank you.